Hi everyone, welcome back again to the Education Diary, day number one of the Advanced Object Detection by using YOLO. So today's webinar is going to be something really interesting in which we are going to be working on some models, some coding, and of course we are going to be checking out that how we can actually go for the Advanced Object Detection by using YOLO. So my name is Gurpreet and I am the instructor, the IT instructor at the Education Diary since 3 months. Currently I'm living in South Korea doing up my education or my studies in AI as well as in research in semiconductor and in robotics. So today we are going to be working on some advanced detection. Of course, we may have done this in earlier in the past few weeks. We have done like computer vision techniques, what is computer vision, what is big data, what is data analytics, and so on things. But today we are going to be proceeding forward with something with the name YOLO. Now that is also something which is very easy, very basic. Some of you already know about YOLO, but people who don't know about YOLO can actually proceed with this particular thing, and it is something which is really great. So yeah, let's start. Let's try to understand that what is YOLO. So first of all, if I'm going to search about YOLO, so here you can see that it is basically you only look once. Now it's basically a kind of library which is basically used in detecting, right? So we can basically do object detection, we can do object character recognition, we can do scene text recognition, which is STR, OD, which is OCR. So these different kind of things can be done by using YOLO. Now YOLO, apart from YOLO, we do have some multiple options, right? We can basically have OCR, which is easy OCR, which is Tesseract. Like we are having multiple libraries, right? But YOLO is something which is used widely by the companies also, as well as by the private organizations also. All right, so apart from that, YOLO is having multiple versions. So we have YOLO version 5, YOLO version 8, and recently YOLO version 9 has been introduced into the market. But majorly, if we go, then YOLO version 8 is something which is majorly used, or we can go with YOLO version 5, right? So if I write YOLO version 5, so here you can see we are having YOLO v5. The project is the open source and it is on the GitHub community. Of course, you can go and you can read what is the F1 score, accuracy and speed of the YOLO version 5 by looking here, right? So these are some of the parameters, these are some of the latency. So yep, here you can see that what is YOLO version 8 performance, YOLO version 7 performance, YOLO version 6 2.0, and YOLO version 5 7.0 performances. So these are some of the very basic things which you can go, of course, if you're not coming from the IT background, but still these are some really basic things which you can check on by going on to the GitHub community, or you can go with the documentations of the YOLO versions, right? Now yeah, let's proceed forward. So as usual, I said that YOLO is something which is majorly used in object detection. In the big data, we are having a website with the name Kaggle, which is basically having the datas, right? Data sets, which can be used for the data analytics purposes, for time series prediction analysis. Yeah, so we are having tons and tons of use cases of using the text data. It can be based on the 5 years of data, 10 years of data. Like, of course, the more data you have, the better the performance of the model is going to be. In the same way, if we want to have a data in images, right? So yeah, Kaggle is also having images, but Kaggle is having more CSV files or TXT files. So yeah, for the images, we are basically going for the RoboFlow. Now RoboFlow is also a website which is having tons and tons of different, we can say, models based on the requirements. Here you can see we are having some traffic sign detection which is having 435 images with the 8 classes. Now what is a class? We are going to understand this in a very basic manner in the meantime, because students do have confusion that what is a class, right? What do you mean by different classes? So yeah, here you can see this is a data set of objecting the fish, right? So it's basically fish recognition. It is having 4452 images, more than 4,000 images, right? Apart from that, you are going to be having board game pandemic cube tracking. You are having metal sheet A5 5 cam 3248 images. We are having some home detection or house detection. These are some human action recognition. These are some 95 cents. So you are having multiple different categories, and based on that you are having, that images, right? You are having some data set. Now the best thing today we are going to understand from the very basic example is going to be, once you visit this website, you can basically log in. Here you can see I've logged in into the website. I'm simply going to search for fire. So today we are going to be detecting fire in an image. of course you can implement this particular project into your university or in your college or in your CCTV based on the Arduino. And once you actually have this project in your CCTV, so that is something in the future, like suppose there is a fire next to your CCTV, so the CCTV can actually capture that. All right, but today we are not going to be very advanced, we are going to be very, very basic. So once basically I search for fire, now we are having so many different multiple that models. Here we are having 1721 images with a 1 class. We are having 1235 images with the 10 classes, 2953 images with the 1 class, 3000 images. So the more images we have, the better the model will be running. But as usual, here is an option has a model. Because we are using YOLO, so we are going to be searching this has a model because we want to implement this into a model. And here we are having fire, we are having 9000 images with the 11 classes, we are having 3000 images with the 1 classes. I think so we should take something which is small, right? Because if we are going to take lots of images, it is going to take a lot of time. So what I'm going to do is I'm going to take something, let's take 3306 images. Let's do this one, the first one. Now, once actually you click here, you are going to be having the MAP score, precision score, and recall score. This is really, really important, right? Because if you are having the precision score less than 50%, 60%, so you can see that the accuracy of the model is something very low. So you should have a score of more than 90% in every category, MAP, precision, as well as recall. Don't worry for the MAP and recall, just check for the precision, that what is actually the accuracy of the model. So if it is like more than 94%, it's a good model. All right, so here you can see that it is having 95%. If I'm going to check for any other model, like suppose if I select this model, now this is having a precision of 85%, it is also a good one, right? But suppose if any model is having 40%, 32%, 50%, so of course you can see that it is not having so much accuracy as well as precision. So let's go with this fire one having 95% accuracy. What I can do is I can simply go to the view full project, and it is going to take me the project. Now here actually you can drop any image and you can see if it is working or no. This is something working in a real time, right? But what I'm going to do is I'm going to simply click on the model here in the fourth option, and here you are having 3000 images. As usual, you can see more than 3000 images, and you are having this particular thing, and here you can see it is written that 83% is the accuracy, that is this particular thing is a fire in an image, right? So what I'm going to do is I'm going to simply click on this download this data set. Now of course RoboFlow offers you totally free things, so you don't need to actually pay anything. Now what I'm going to do is I'm going to be selecting YOLO version 8. As usual, you can download in CSV files, you can download in any other library if you want, you can download in YOLO version 5. But YOLO version 8 is something today we are going to work because it is having much more accuracy based on the other YOLO versions. So I'm going to, now here you can download the zip of all these images into your computer, or I'm going to do show code because I'm going to be working online, so I just need the download code, right? But before that I have opened a like pre-default website that how can you actually train a model by using RoboFlow for your own purposes. Now this is a website we are going to take help from, and this is actually the Google Colab I have already opened, right? So we are going to write code here and we are going to train a model, we are going to upload an image, and we are going to see that if the model can recognize the fire or no. Now before proceeding in the Google Colab, make sure you have to go in this option, change runtime to the T4 GPU, because Google Colab is not going to be working on CPU. Of course it will work, but it will take tons and tons of time, right? It will going to take a lot of time. So what if you go with the T4 GPU, which is a free version, and it is also provide us the GPU. So once we click on save, we can basically go and connect to the runtime. So now it is actually connecting to the Python 3 Google Compute Engine backend. So we have to use the power of GPU. Otherwise, if you are going to be working on CPU, so it is going to take like, that more than 60, 70, 80 hours of work. Now here you can see that it is basically connected with the backend of the GPU. RAM is 12 GB, disk is 78 GB, which is provided. Now we can go and proceed with the model. So we are having this. Let's go click on continue, starting download. And it is going to provide us the key or the code through which we can download this particular project. All right, now this is my API key in this. You can see basically it is hidden, right? So let me try to zoom. So you can see that this is actually the code which we have to copy in our Google Colab, and here is my API key through which the model is going to be downloaded into my Google Colab. Now of course, if you are going to visit here, you are going to have your own API key. Now if you go, you can install via terminal, you can simply install via URL, but as usual I'm using Google Colab, which is the online cloud version of using Python, so I can basically go and proceed with the Google Colab. Before that, let's follow the steps of how to train YOLO version 8 object detection on a custom dataset. And before that, let's try to download any fire image. Now here is a fire image. We can download any fire image just to test that how is it going. So I'm going to do right click, save image as. So we are going to save image as this on the desktop. Let's click on save and let's see if the image has been saved into the JPG format. So that's totally fine. Now this image we are going to detect at the very last. So let's follow these steps, which is basically being told here. So first of all, this is before you start, make sure to load all of your requirements into the Google Colab. So here, if I paste here, so it's going to be giving the responses of my Google Colab, that how much is the GPU storage, how much is the CPU usage, processing power and everything. So it's nothing very important, right? We go to the next line, next code, and we are going to be having printing the home. Right now, of course, we can write, but it is going to take a lot of time. So that's why I'm not writing the code. But yeah, you can actually take help. All right, let's go forward with the content. And we are going to be having install YOLO version 8 in your Google Colab. So now we are going to be installing YOLO version 8 in our Google Colab. So let's copy this, let's paste it here and let's run this. Now it is going to take some time to install the YOLO version 8. Now, as usual, it might take some time, not much, but yeah. Let's wait for some time. Until then, let's click on the code so that the next panel is basically being opened. All right, and if you do have any questions, so make sure to comment down onto the YouTube channel, or if you do have any questions, so you can actually send an email to the education diary. Now, as usual, it is basically collecting all the requirements which are necessary, important in order to use YOLO version 8. But as usual, if you want, you can go with the YOLO version 9. But that is something in the under development. It's not basically being, we can say, having more accuracy. But YOLO version 5 and YOLO version 8 are something which are widely used by the people in the projects. So I would suggest to go with the YOLO version 8. But if you want, you can go with the YOLO version 5. Now inside these YOLO versions, you are having some different categories, right? So suppose if I take YOLO version 8, so in YOLO version 8, we are having version 8 nano, version 8 small, version 8 large. So based on what is your requirement, so you can use those different categories in YOLO version. All right, so now it is basically taking some time. Let's wait. And here you can see setup is completed, blah, blah, blah. So it is basically installed. Now what we can do is we can go next. Now we are basically going to take this from Ultralytics. So it's going to be displaying our results here. So if I hit this run, now that's totally fine. Let's go to the next code. And by the way, I can open up my file manager, and here you can see there is nothing installed right now. Okay. Now this is leave it, CLI basics, doesn't matter. Now this is also not required, right? This is something which is only an example. What is basically required is basically installing the RoboFlow library, which we want a model. And here we are. All right, so here we are. We can basically install our RoboFlow library from here. Now this is an example. Let's copy it here and let's paste in our Google Colab. So once if I'm going to install this, it's going to be installing here. Okay, so now this is the model of 3000 images. Now, of course, it is going to take some time. But yeah, once it is being installed, so you can actually see the folder here that yes, now here you can see restart session. Of course, it's a very big library. We have to restart session again. It's giving some kind of error. So yeah, now it's connected. Now it's running. So in the restart session means that it is going to take a lot of memory. So make sure to restart your session and you can restart or run the commands again if there is any kind of problem. So no problem in that. Now everything is installed. I think so. It is installed. Now this was my API key. If I refresh my panel, so here you can see now we are having our model with the name Fire1. Okay. So here you can see that if I'm having Fire1, it should be opened. So now let's wait. So what I can do is I can try to delete this because it's not opening and maybe there was a problem. Let's restart this. it's going to say restart session. So if it's going to say, then that's fine, we can restart, but the folder should be opened, right? Because inside that we are having our images, annotations, we are having labels, and importantly, one important file, which is data.yaml. So let's wait. It's installing. Now here you can see downloading dataset version file 1 to the YOLO version 8, and it's going to take extracting dataset version. So it's done. If I refresh my file manager, so here we are having file 1. So yep, now it's opening. So suppose if sometimes if a dataset is not opening, make sure to delete it, run the command again from the Google Colab, and it will be downloaded. Now inside this folder, you are having a testing folder, training folder, and a valid folder. Now this is really important, and you should have the fourth important file, which is the data.yaml. All right. Now testing, training, and validating is something a part of training a model. Everyone knows. But yeah, you can also go and make your own images. You can make a model of your own images, but it is going to take a lot of time. All right, because you have to take images, like lots of images, 1000 images, and in each image you have to create some boundary boxes or some labels, right? So it's going to take a lot of time. So instead we can take a model which is already there available, but I'm just explaining you that yes, these are also the things which you can do. Now once actually our data set is completed, so what we can do is, now here it is telling us to train the model, right? Now this is something a really important thing. You have to train your model by using YOLO version 8. So what I can do is I can go in the code, and I have to make some changes here. So it is basically taking YOLO 8s, right? So 8s is basically 8 small. You can take 8n. N basically means nano, but let's go with the S and let's see if the model is able to work or no. And after that, the dataset location, data.yaml. So we are going to delete this, and we are going to copy this data.yaml location from here, and we are going to paste the location here. Now this is the location of data.yaml, and everything is fine. But before that, you have to double click on data.yaml, and you have to change the what we can say, the file location. So this is actually wrong. Test that we have to take the images from here. Let's copy the path from here of the testing. Make sure to have a space after the test. Don't make it close, otherwise it's not going to work. For the training, we have to change the label or the path. So let's go here, copy this, paste the location or the path here. Valid is something this. Let's go copy path from here. Now this is actually not mentioned in the that blog, but I'm telling you here. So make sure to save the file, this data.yml file, by Control S or Command S. Now this is being saving. Now saved successfully. Let's close this, and now let's run. It should work. So we are taking epochs 25 and image size is 800. Now this is actually going to train the model. Okay, so right now we are going to train the model. Let's see, hopefully it should work. Otherwise, if it's exceeding the GPU power, so we have to change the model because it is having 3000 images. We are using free version of GPU of the Google Colab. It should work, but somehow if it's not working, so we have to change the model with the less images. All right, now it is running and working. So let's wait. It should start. Now here you can see that epochs. Now this is actually the training of the model, and this is really important. Now the model is actually working. We are going to make a model. Now it's going to take some time, and in the folder section you can see that some extra files are being added. We have taken 25 epochs. The more epochs you have, the better it is, but if you are having more epochs, so it might do overlapping. Now this process is also known as fine tuning. That means you are trying to make a model and adjust the model based on different parameters, like we can increase the epochs, we can increase the image size. But here you can see for one epoch it is already taking some time, right? So instead we should have used the 8n because S is going to take some time. So we should have to wait for at least 10 or 15 minutes if I'm not wrong, because it's going to take some time. Or if you want, we can go with the N. So I'm thinking to go with the N. Let's stop this, and I think so we should take the nano version because it's pretty fast. Right now it's only 37% of only one epoch, 38% of one epoch. So let's go with the N version. I can simply stop it by clicking on here, and it is going to give me some kind of error. Now what I can do is I can simply delete this runs folder because it is having all these things. It can't be deleted, so no problem. Let's delete this 8n. Okay, 8s, which we have used, by the way. So yeah, let's rerun this, and instead of 8s, I'm going to take 8n. Okay, so if you can see here, so I'm using model YOLO version 8n.pt because it is a nano version, so it's going to be fast. So if I rerun, hopefully it should run and it should give me more speed. Okay, so let's see. And in the GPU, you can see that it's taking a lot of memory, right? In the here, you can see that disk is already 30 GB filled on. Now this process should be fast. All right, so it started. Yeah, it's kind of like fast, more fast than the previous version, right? So it's basically working fast. Let's give us some time to it, and in the meantime we can basically go and can check for the more and more data set. Now this is something which we don't need, right? But yeah, the important thing is you can actually go into the model section and you can try with your own webcam. Now this is a very good thing. If you go and if you want to see, you can just have an image actually downloaded on your phone, and you just show your phone on the camera of your laptop, so it can actually try to detect. So in that also you can actually get an hint that yes, it's working or no. Right now this is something that's fine. We can close this, and this is the major website having the precision and accuracy. So yep, now it's basically 32%. Yeah, it's going to take some time. It's really going to take some time. All right, because training a model actually takes a long time. By the way, let me know in the comment section if you're watching the video that right now what you're doing, what's your major, and have you ever used this YOLO or no, and if you have used, in what project you have used this YOLO. All right, so basically I can change the epoch size to 20 or 15, but I personally don't want to do that because 25 is at least we should give to the model so that it can have some at least accuracy to that particular image which we are going to upload. All right, now 1 minute and 32 seconds has been taken by only the first epoch, and it has to complete 25 epochs in time. So let's wait. Now everything depends on the model size also. I have taken a 3000 images model size to make the model more accurate. So if the model is only having 500 300 images, so it doesn't take a lot of time, it gives us only in 2 minutes. But I've taken a very huge model, so it's going to take some time. But the more images your model is having, the better the accuracy of that model is. Okay, so yeah, the people, the organizations or companies do use models which are having, you know, that hundreds and thousands of images, so that their model is having more accuracy. Now only first epoch is taking 90%, so we have to complete all 25 epochs. That is something which we have to wait for. Now as usual, you can see that the second epoch has been started, right? It is also going to take some time, and we have to wait for almost 25 epochs. So in the meantime, let's study about what is epoch in AI or in machine learning, where all the training data is used at once, and it is defined the total number of iterations of all the training data in one cycle for training the machine learning model, right? So what we can check is YOLO version 8, different model accuracy. So if I go into the ultralytics, so here you can see that this is something, the YOLO version 8. By the way, you can go and you can study from here as well. Now this is something which is really great, right? So here you can see we are using YOLO v8n.pt, which is the YOLO version 8 model, and it is basically used for detection, right? Yep, that's fine. And there is YOLO version 8 segmentation, right? So we are having this kind of thing. So instead of YOLO v89 where I changed, you have to write this, and it is basically used for instance segmentation and pause key points, oriented detection, classification. So you are having different YOLO models and YOLO versions. All right, performance metrics is something which is being given here, which is really important for us because I'm using YOLO version 8N. So the pixel size is going to be 640, MAP value is going to be between 37.3, speed in terms of CPU is 80.4, parameters 3.2, flops 8.7. But from here, from this table, actually you can get that what is something which is more important, which is something more better, right? Now the highest value is going to be, I personally believe so, version 8X, right? It is having the highest value. Of course, it is going to be taking a very, very long time because it will be huge, right? Nano is something very small. S basically means small, M means medium, L means large, and X means extra large size. So yep, I am using the V89. So this is also matters. This also matters. If you are going to use YOLO version 8S, so the parameters or the, that accuracy will be more increased. If you are going to use X, it is going to take a lot of time, but of course the accuracy is going to be increased. So if you are using GPU, Google Cloud GPU, which I'm using, of course, so here you can see it is still on the second epoch. So we have to wait till the 25 of the epochs. And yeah, if you are going to be using some different, like suppose 800 GPU, L4 GPU, V100 GPU, so these are actually something which you have to upgrade your collab, right, in order to get the GPU. But I am using the free GPU version which the Google Colab is providing, so that's totally fine with me. And the epochs are being done. It will take some time. So in the runs, actually, if I go, so it, as you can see that there is a folder with the name runs. If I go into the detect, right, so let me share up my screen. Yeah, here actually you can see there is a folder with the name runs. We are having a detect, we are having train 2, we are having train, and I personally believe so that after this this particular folder is going to be having the important values, right? So as you can see, we are having train and train 2, two different folders. Train 2 was something which was being taken previously, which I personally stopped, right? So that is actually something by default, and this train folder should be the one which we are using. And inside this we are going to be having our, what we can say, F1 score, precision, and every graph in the weights. Right now it is actually working, so that's why it's not opening, because our model is right now running and training. In the train 2, if I go and if I go into the weights, let's see if it's opening or no. Yeah, it is opening, and we are having best.pt and last.pt, which are two important files. So best.pt is something, the model, this is our model, okay, which is going to be used in order to detect the fire in our image. So this particular file is really important. All right, but let's see, let's wait for our model to complete its running, and we can close. Let's do this and zoom out the screen. So epoch is right now on the 3. It's going to take some time, really. All right, so yep, overall this is the YOLO. And what I can show you next thing is, by the way, you might encounter, if you're like, suppose if I want to use any AI, I personally want to suggest use Cloud AI. Yeah, right now if I want to write any kind of programming code in Python or in any kind of programming language, so I personally use Cloud AI. I don't use the chat GPT, because if you go into the Cloud AI, so it basically gives you a good programming language code which is like easily used in the Google Colab or anywhere. All right, so if you want to go with the Cloud AI, I personally don't use ChatGPT much, but Cloud AI is something with the ChatGPT 4. You can actually, that upload any kind of files, images, and based on that image, you can ask the questions based on the PDF, based on the Excel sheet. You can ask Cloud to basically give you the answers. All right, you can also upgrade your Cloud AI. So let me know if you use Cloud or no, because I personally use Cloud AI. All right, now actually here you can see that once actually our training is going to be done, now this is the blog. Here you can see it is also taking a lot of time. Right now this is by default already being done. And once it's done, so you're going to be having something like a graph, so you can actually see the precision scores again if you want. And this is going to be your F1 score metrics, train metrics, and something like that. And at the very last, you are going to be using or uploading your image to check about is it working or no. Okay, so it's going to be not very difficult. And here we are going to be displaying in Python image. So yep, that's something which is fine. What I personally want is, once the epochs are completed, so we just need to go and run this kind of command. All right, so this command is going to be running, and yeah, that's it, nothing else. So we can also run this command, right? Test images, where we are going to be having our images in the source. So let's wait for our model to run. Now the epoch is 4. It's going to take some time, so till then actually you can let me know any other problems if you want on the YouTube comment section. Could you show any classification algorithm or any ML algorithm which with AI and show me the epochs? So as usual for classification algorithms, we are having different one. We are having KNN, right? We are having RCNN, we are having normally CNN, we are having STM, we are having OCR. So these are actually some different models, right, which are basically being used with the AI and machine learning. Now this is something which is having pre-default model, or we can say the data sets inside that. Suppose let's take an example of easy OCR. Now, if you don't know about easy OCR, now this is something which is very famous for the object character recognition. Right now, this is a model. All right. Now, as usual, classification means the term classification actually means that we basically classify the model into different classes and subsets of that. All right. So suppose if I go into the easy OCR, so what I can do is I can basically go and check for the precision of this. All right, so basically you can go and you are having some of the blogs in which you can read. Right now, this is actually the Tesseract Keras OCR versus Easy OCR. Right, and here you are going to maybe having some data about which is having more accuracy. So here you are having, basically you can go with this, right? Now, Easy OCR, when I'm using Easy OCR, so it doesn't require epochs. Okay, it doesn't require any kind of epochs, but is already having. Okay, so if I want to use easy OCR, I don't need any kind of epoch, but because it is already having it in itself. Okay, so if I want to use easy OCR in my Google Colab, I personally used easy OCR recently in one of a project. So it doesn't require any kind of epoch. You just basically need to install the easy OCR in your Google Colab, and you just need to go and start with that. Okay, same goes with the Tesseract, same goes with the other OCR, but yeah, that is something really important. So algorithms are something which you have to make, right? So suppose let's take very easy example of an algorithm, like we are having linear regression or we are having logistic regressions, or we can also go with something the time series data analytical data, or that is also an algorithm, time series algorithm. All right, so if we go with the time series algorithm or time series algorithm, so basically you can see that we are having time series forecasting algorithms. So here we are. So these are some of the time series algorithm. Right, using cloud AI, can you write any ML code and implementation for XCard price prediction or diabetes? Yeah, of course, by using cloud AI, as I told you that you can basically go with any kind of, like personally I use cloud AI. Okay, ChatGPT gives you the code, but it doesn't work properly sometimes. But cloud AI is something which I personally use in coding problems. But yeah, apart from that, if you are working on some data set which is a text, so you have to go with the Kaggle website, which is having tons and tons of text data set. But if you want to work on image data set, so go with the RoboFlow. Okay, now this is something the time series analytical algorithms. Now what is time series predictive algorithms is that it basically predicts, right? So predictive algorithms, we can say autoregressive, integrated moving average, ARIMA, SARIMA, ES. Now you can basically say out of these 10, I only know 2 or 3, right? Because as usual, we don't study every algorithm. Once you are going to be studying every algorithm, it's going to be really hard for you to, that go dig deep inside that. Right now, we just work on it LSTM, which is, of course, everyone knows LSTM, right? It's basically used in deep learning. We have been working with this temporal fusion transformer, Google, and somewhere we know autoregressive model AR. So out of these 10, we personally worked only on 3, because as usual you don't need to know all the algorithms because it's going to be really hectic for you. Okay, so as usual, we basically do some research All right, so suppose if I show you some research papers, so you have to study some, let's see if our model is at 6. We are having lots of time. Okay, so yeah, let's have some more conversations. So we basically what do is we basically write some research papers. As usual, we have to publish some of the research papers, and we are not going to study all these algorithms because that is not our field. What is our field is that suppose we just take an algorithm, autoregressive. Now inside autoregressive, we have to understand more and more in depth, and we have to find a problem, and then we have to find a solution or a better solution for the pre-existing solution which other person or other authors have written. So that is something totally fine. If you don't know all the 10 algorithms, that is totally fine. But if you do know some one or two algorithms from this list, it's good. It's a good going. All right. So yeah, these all models are basically like this autoregressive model is basically a classification algorithm, right? It basically classifies between different classes and different subsets. LSTM is also a classification algorithm, and temporal fusion transformer is basically a hybrid model. All right, so if I take autoregressive, so yeah, it's basically based on classification model. And of course, if we are like classification actually means that if we are having a car, okay, I basically forget to tell you that what do you mean by the word classes, right? So here you are having one classes. So the classes actually means that if we are having a BMW, we are having a car BMW, but BMW is having different models. All right, so the car BMW is the company, but the company is having some different models, BMW blah, BMW blah blah, and we have to detect each model of BMW in a camera, in a CCTV. So that is something really hard for a CCTV to capture every different model of BMW, because somewhere in the image we are going to be having the logo of BMW. All right, so the camera can capture that yes, this is BMW, but when it comes to detect what model of BMW it is, it's going to be hard for the camera to capture. All right, that's really a very, we can say, hectic for the camera to understand. And that is where the classes comes. So if an image is having fire, and a fire is basically of orange color in some images, this is one class. If a fire is in the form of we can say lighter, right? So we are having fire lighter. So in the term of lighter, we are having a second class. The fire is basically something in a picnic spot, right? So people are having fire in a picnic spot. So this is going to be your third class. But ultimately you can see that we are having fire, but on different locations, on different circumstances. So this is actually going to be classes. So if we are having BMW cars, we are having tons and tons of, we are having thousands of images of BMW of different models. So we have to tell to the model in every class that yes, this class has or needs to be of this model. So we basically train the class based on that model. Then we go to the next class, we train the model on that different model of the car. So maybe you are able to understand that what actually the classes means in the model training or the machine learning. All right, so this is very simple and basic example I'm giving you. I'm not going into the very IT definitions which we do have because it's really confusing. All right, so could you show KNN ML algorithm in Cloud AI just to understand that how to use, since you are industry it will help you for blah 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 beginner. So KNN, let's go with the cloud. Okay, so Cloud AI, let's go. By the way, you can upgrade your, it's very cheap, right? So KNN machine learning. So what we can do is we can simply write KNN machine learning algorithm code in Python. So here you can see it is going to giving us the library of using NumPy as NP, collections import counter, and so many different things. Now it is also going to be telling you the Euclidean distance. Functions calculate the Euclidean distance between two data points. The KNN class is going to be having initiative of the K value as well as the training and Y training model, fit predictions of the X values. And here we are having an example which we can go. Now this is the basic implementation of KNN algorithm. You can further enhance. Now this is something the KNN algorithm looks like. All right, so now this is going to be something which is the algorithm looks like. Now but suppose if I'm working on Google Cloud, I'm not using on PyCharm. That is really important because I'm using Google Cloud. So I can say give the code based on the Google Colab. Give the code based on Google Colab, because it is going to give us the code based on the PyCharm or any other Python IDE, right? So here it's going to be giving us about the Google Colab version. And but here it's basically asking import the necessary libraries like NumPy, numerical operations, define the Euclidean distance function to calculate, define the knn, xtrain, ytrain, create an instance of the knn class with k3 and blah blah blah. So here you can see it is basically giving us the code. All right, now I'm not going to be copying and pasting it in my Google Colab because there is already a function which is working there. So that is something going to create an error. I'm using a GPU as well as a free version, so I cannot go with that. But yep, so knn is something which tells you the nearest neighbor. All right, it's basically a classification model in which basically it tells you the nearest data points. Now knn algorithm is basically used in exoplanet research. Now I'm telling you that if I go with the knn model, so knn algorithm for exoplanet. So here you can see that we are having knn. Like now personally I use this, right? I used knn in my last year. I used knn for the exoplanet research by using NASA's technologies and so many things. So yep, here you can see this particular person has used knn for classifying the different exoplanets which are out of our space, right? And you can see including kn decision trees to identify exoplanets in astronomical data. All right, and here it is basically having the Google Colab file. So basically you can go and you can open this Google Colab file, right? By the way, if you also want to go with the NASA knn algorithm, so if you are going to write this, you are going to be having the study from the NASA directly, and this is something the NASA itself uses knn. All right, so personally if you ask me, knn is one of a very great library or a model which can be used in classifications. And yep, that's it. All right, so apart from that, if you do have any other questions, do ask me. By the way, I cannot execute any code on my Google Colab right now because you can see that the model is getting trained, and if I'm going to execute, so the model is going to be collapsed and we have to run again. So let's wait for our model. Now out of 25 only 8 has been completed, so we are having almost more than like 10 or 15 minutes to go on. All right, so I do personally believe so that I should have taken a very small size of data set. I have taken a very huge data set which is 3000 images, but yep, let it be. So in the meantime, if I go into the Fire model which we have, and if I try this model, if I upload my image, let's see if it can detect or no. So here you can see that it is latest, and you can see that there it basically detected 81%. All right, so the model has basically detected the fire from my image. But as usual, this is something which is working online. What I want to show you is that suppose if you are going to be having the best.pt file, which is your model, right? So that is something how you can do. As I told you that in runs, you are going to be having best.pt file, which is going to be your model. So you can use this best.pt anywhere. You can send this to your colleague or in your team, so that different members can try different that images. And if there is any kind of image which it's unable to detect, so you can actually increase the epoch size, or you can increase the image size. That is something which you can do. All right, so yep, any other thing which I can help you guys with? So by the way, research is really important. If you are in the field of IT, and if you're not updating or upgrading yourself time to time, so it's going to be really hard for you. Because of the coming of AI, now the job market is really congested, right? So you have to upgrade yourself in every field, in cybersecurity, in ethical hacking, in big data, in your machine learning, AI technology. So try to have skills in different categories. Don't focus on only one category. That is something not going to be working with you easily. All right, so if I show you about what we can say, if I show you my paper, so idpr.org UK, so here you can see that my research paper has been submitted in one of Scopus Index journal. So if I go and I can search for assessing the impact, not this one, let's go, yep, here we can see. Now this is a research paper which I have published, and I would personally suggest you guys also to go and research and try to publish If there is any kind of problem you find, try to find a solution for that or a better solution for that, right? So suppose you can see that I have published a research paper and I'm the first author and there is a professor who is the second person. So you can basically go and you can access the PDF file of this research paper. And yeah, this is basically based in cybersecurity. So as soon as we find any kind of problem, so here you can see that this is my university, which is the Wusong University in South Korea. And the professor is also from the Wusong University. And this is something, a research paper of 20 papers. All right. So you have to find the problems, then you have to write a solution for that. And at the last, you have to write some conclusions. Now this is based in cybersecurity. So that is something really important. As I'm telling you that make sure to have some research papers. Now suppose if I'm going to be doing any kind of YOLO version 8 in epoch and I find that by using 30 epochs I am having this accuracy, or by using 25 epochs I am having this accuracy. So there is a difference between using 30 and 25. So you can actually go and write a paper on that. Okay, so it should be logical. All right. Oh, it's done almost 10 epochs. We have 15 more to go. It's going to take some time, really. So in the meantime, I can also show you some OCR in the RoboFlow. If I search for OCR, now this is something, the object character recognition. So once again has a model. Suppose if you want to use with the YOLO version 8 or YOLO version 5. So here you can see it is having how many images? 137 images. So underline detection. So if any word is having underline, so this particular model is going to detect the underline in that image. In this OCR detection, we are having 325 images with 132 different classes, right? We are having handwriting detection only with the 87 images. We are having detector memes. So we are having scissors, we are having text recognitions, we are having text objects, right? We are like having tons and tons of different models. We can also go with the barcode. So if I want to search or detect barcode in any kind of image, so you can see that here we are. So now this particular model can detect the barcode in an image or in a video, segmentation barcode, barcode detection dataset, 1000 images, 165 images, and 846 images. So try to have more images with more classes. So this is something 2000 images. This should work perfectly. Now suppose if I go in any one of them, like suppose if I go into 2000 images and if I go to the view full project, let's see the precision score. So what's the precision? If I go to the overview, let's go to the model. So we cannot basically work with this model. Okay, it's not being permitted. So let's go with this 846 images. So you can see precision is 100%. So 100% accuracy is basically of this model barcode detection. All right. So yep. So 99% of this epoch 10. So till then what we can do, we can try to upload our image into the Google Colab. Okay, so it will be deleted after some time, so it doesn't matter. What we want is, so our image is basically being uploaded into the Google Colab. Okay, once our model is completed, we are going to use our image to detect again, and we can try with some different images also. Let's go and let's download any other image if we can. Okay, let's download this one. So save image as, so images, desktop, that's fine. Let's upload this also. It's in JPEG. Let's say I've developed the ML model, how to check and implement in live and test whether the model is working fine or not. For example, diabetics predictions. Can you show me, Kaggle, how to execute? I have a question. How Google Lens application is developed? So if you have to develop an ML model, how to check and implement in live and test whether the model is working for diabetes prediction. So yeah, you can actually go and search for Kaggle, right? So if I go on Kaggle, now here you can see for machine learning and data science community, you have to sign up or sign in. And once you sign in, if I search here, so I can search for diabetes. All right, so diabetes dataset. So once basically I search this, so here you can see you are having so many different data sets. If you go and search for large dataset size, because as usual I told you, the more data you have, the better it is. The next thing is you basically have to check for the downloads, right? How many downloads are there? So here you are going to be having some of the diabetes dataset or no. So this is something resized, eye disease detection dataset, COVID, diabetic, retinal image dataset. So if I go now, maybe it's not having. So let's go and search. So here you can see we are having KNN diabetes dataset. All right. So we are having this one. So you can actually go with this. All right. And if I want the file in the CSV, so I can basically go filter here. So diabetes dataset, 92,000 downloads. And here we are. All right. So it is basically a diabetes.csv file. You are going to be having only 23 KB of size, and you can basically download the CSV file from here. As usual, you have to sign in or register on the Kaggle website. But yeah, once you have downloaded, then you can ask the cloud AI that this is actually the CSV file having this different forms of, we can say, rows and columns. And based on that, you want to have some predictive algorithm for that, or you want to have a predictive program which can actually, suppose if you enter a kind of score 92.5, so it can actually tell that is it diabetic or no, or if within some few coming days the person is going to be having diabetes, more diabetes or less diabetes. That is something you can go and work with, right? This is just an idea. I'm just giving an idea that what processes can you actually go and apply for. Okay, so yeah, as I told you, I'm not into these different things, right? We do work on these things, but my major field is basically the AI machine learning. I'm not like used to CSV files. Okay, but yeah, this is the process my colleagues do use. All right, 12 epochs has been done so far, almost 50%. All right, and next question was like how how Google Lens application is developed. I'm not sure. Maybe they have used C++ language if I'm not wrong. I've never searched about this. So Google Lens programming language. All right. So what technology, image recognition, and AI. So yeah, actually, personally, I would suggest that if you want to learn any programming language, go with the C++ programming language. It's majorly being used, right? Or the R programming language. So if like you want to develop any kind of program, like you said, you want to develop a program or kind of an application in the diabetes, go and learn C++. Or if you want, you have to use the big data or these different data sets, go with the R programming language. All right. So Python is something which is not majorly used. If you know Python and if you go into the industry, if you want to get a job in industry by learning only Python, so that is something you can get. But if a person knows C++ or C sharp or C language or R language, so they will be preferred more. So personally, if you ask me, do I know Python? I would say that I don't work in Python so much. I only work in C++. Right, I don't even know R programming language because as usual, I do focus only on C++ and we do develop applications and programs, Windows applications, Mac applications. So yeah, C++ is something which is majorly used. Go with that. And I personally believe so that whatever the applications you're using right now, even Google Chrome, Google Lens, all these applications are basically based on the C++ frameworks. All right. So yeah, that's something you have to research and go and check on. All right. So almost 12 epochs has been completed with a 91%. So yep, if any of you do have any other questions related to the education diary, you can actually text us, right? So yep. Now, living in South Korea, I would personally want to share that in South Korea, people do know Python, but as usual, Koreans do know C++. And that is something which is majorly being interesting for the Koreans, because if you know C++, so you can actually go in the hackathon competitions or coding competitions. But if you know Python, so it's kind of like right, but not very much interesting for the people. All right. So what else we can do? I think so that is something which was overall we can discuss on. But if you do have any other questions, so do let me know. And at the very last, I think so this is only going to be the command which we are going to use. So let's copy this command. And I think so what we can do is let's open a code so that once it's done, we can go. Now here you can see ICT model, prediction model in runs detect. So we have to change this, right? We have to change this .pt file here. As I told you, best.pt is going to be something really important file. So you have to have this best.pt, and this is only going to be done when your model is going to be trained. We can say the model finishes its training. Conference is going to be 0.25. Source, what is going to be our source image? All right, so what is going to be the source image? So we are going to be doing it here. So let's wait. What EU developed in C++, more info please. So recently we are working with a company with the name GMD Soft. Now this is one of a very great company in Korea, and this is basically used in the forensic solution, right? So if you go here, you are going to be having softwares, and we basically have contributed in that. As I told you that creating an application requires certain steps, all right? So suppose you have to go for your testing data, then different people are going to be using that application in the company, right? And then basically they are going to be testing for any kind of vulnerabilities or bugs. And based on that, you are basically going to be having the very last, we can say, finalized software. Then of course the public is going to be using, not all, but some developers, as we are having Sora AI. So Sora AI is basically being used by the red teamers first, so that they can check for any kind of weaknesses, and then only it is basically being that go into the public. So here you can see that this is actually the company, and if you go into the products, so we are having these different kinds of products, right? So we are having mobile forensic software, digital forensic software, mobile forensic hardware, mobile forensic package. All right, so this is something being compared with a Google company. All right, so as usual, these are some of the softwares you can download, and these softwares are written in C++ and of course in Django, but C++ is majorly being used. All right, so if I go, MD Next is the name of the software, MD Red. Now this is something, the drone video AI. Now this software is basically you upload a video, and suppose if there is kind of like a video in which there is a car, there's a criminal in a car, and he's that having a very huge speed of the car. The number plate is blurry. So the number plate in that video is blurry. So by using these kind of digital forensic softwares, you can actually go in that video and you can clear the image of that number plate. All right, so of course this is very helpful for the police, so that they can track down the criminal. So that is something, this is basically being used, the video AI. In the video AI, in the software, you can also what we can say, cut the time which you actually don't need, right? So suppose in the whole day of a CCTV footage, I just need a person who wears a red jacket, and I don't need the whole day CCTV, right? Because it is going to take the whole day for a person to investigate, only for one moment in which that person with a red jacket has been passed. So by using this AI, we can give some commands. It is a GUI interface, so you can actually just write some execution codes, and it will give you the timestamp on which the person of the red jacket has passed from that frame. So it will give you an exact frame. Okay, so this basically reduces the human effort and reduces the time for the investigators as well. All right, so I'm learning ML, what kind of projects industry expects. These kind of projects, as I told you, the more you have these kind of projects, the more applications you make, the better it is. Because writing a Python code or writing a code is not going to be giving you anything. You have to develop an application. Like suppose what we are doing here in this Google Colab, right? So we are training a model, and you can create an application. You can upload this kind of model into that application, and whenever there is a fire, so you can actually take out your phone. You can, even if your phone is far from that distance, but you do think that that is a fire or just an orange color, so you can try to zoom in, and then your model can predict if it is a fire or no. So yeah, that is something, a very interesting thing to go on. You can create an application, an Android application or an iOS application, and upload this kind of model there. Okay, so that is something you can do, as like Snapchat or Instagram do every month. They do update or upgrade, or do that introduce some of the new technologies. All right, so why cannot we do same thing with ML applications? So yeah, you can do. All right, so yep, now it's basically 15, only 10 more epochs, and then we are going to be using our YOLO. And yep, as I told you that somehow these commands might create some problem, so you can use cloud AI in order to detect. As I told you, if you are going to be writing the code by yourself, it is going to take some time and you need the knowledge of Python in writing that code. But if you are not like willing to go with that, just use AI, just check out that how the model work, because actually what really matters is that have you created the model or no. So yes, our model is going to be created with the name best.pt, so that is no problem, and we just need to execute last command, upload our image, and just need to check that our model can check or detect the fire in that image or no. Now once again, this model is based only on fire. If you are going to uploading any kind of other things like fish, it is not going to detect that, right? Because the images in the testing training I'm validating is only your fire. So based on that, you can go and search on RoboFlow, or you can go with the human, right? So suppose if I go with the human, so you're going to be having human detections, right? So you're having eyes detect, hand safety. So we are having some AI images, we are having some face detection. So suppose if I just write face detection, so you can go with this, and here we are. So you can see we are having 715 images, 296 images, 241 images with the face detection. And make sure to go with the hazard model. All right, then only you can be use it in your YOLO version. So here also face detection, face detection, face detection. You can go with the emotion recognition if you want. So emotion recognition, and you can upload your own image or anyone's image. So here you are having emotion recognition, right? So emotion detection. So we can go with the emotion detection. Right, so yep, actually you have to go on different model sets, right? So you're having face detection, face expression, facial expression only by 89 images, 3 classes. So the more images it has, the better accuracy it will be having. Emotion classification, facial emotions recognition version 2. So yeah, actually now this is the way I told you, this is going to be the same way you can go with the every model, same process, same commands. Make sure to use YOLO version 8. Don't go with any other YOLO versions. It's going to be taking some time, right? So I'm working for waste management. Waste consists of inert, RDF, C and D. During summertime, heat is catching up automatically because of fire. How to detect that fire is going to happen before 2 days. Now, of course, that personally takes some time and it's hard, right? As I told you that until unless you don't have the data set, you don't have the datas of previous 5 years, 10 years or something like that. So it's hard because the prediction actually is based on the data set, right? So as I told you that if you are having data, so you can actually train the model and you can go with the time series predictive algorithms, which we have discussed today. So time series predictive algorithms can actually go with that, right? And you can actually check on with that. So it's going to be easy for predicting the in future incidents, right? Or using sensor, we can implement that. So yeah, of course, using sensor, you are not going to be having any predictions, right? So sensor is something which works in the real time and gives you the data in the real time. So it is not going to be used in predicting something. As usual, we do have webinar last week based on IoT, right? In which we basically introduced the Arduino's DHT11 sensor, which is basically a very basic sensor for temperature. But as usual, if you go and if you want to go with the predictions in these kind of IoT, it's not going to be possible case. All right, because sensor is something only used in real time and gives you the data in the real time. It basically tells you that if there is a fire, it will tell you by the email or by an alarm based on your, of course, the programming capabilities. But if you want to have some predictions, the IoT is not going to be working really well there. All right. So yep, that is something the important things you need to consider. So it is going to take some time, more and more time, I think so. So let's do wait. And by the way, if you want to get some certifications in any kind of field like IoT, big data, or AI, ML, so please make sure to contact the Education Diary because they are providing these certifications, right? So you can get some certifications in AI. And of course, you are going to be getting in depth knowledge from us, from me personally, right? And how you can actually go for the job interviews and how you can actually work on some great projects, industrial based projects. So you can actually contact the education diary. All right. So I think so only 9 more epochs and then we are having our model ready. But if you are going to be using CPU in terms of this, so it's going to be taking like 7 8 days, so you cannot stop your program to run and you cannot close your computer. All right, so make sure to use GPU. So how remote sensing is working? I have many use cases with remote sensors. Want to do agriculture predictions? Any idea in the sensing? So as usual, you can use sensors in things speak IoT. We are having that Blink software application, which you can go with the remote sensors technology. But as usual, as I told you, that prediction is really hard in that sensors. Okay, for predictions, you have to create an ML algorithm in your server. So once actually your IoT sensor is going to be sending any kind of data, so the server is going to pre-process that data and it will be giving a predicted value to you. So in actually you are not implementing any kind of thing in the sensors, but you are going to be implementing the prediction algorithm in your server. So that is something which you can go for. But if you are only having the idea of remote sensors and getting predictions value, predictive value, so it's not the case. You cannot get that. All right. So epoch is basically training, right? So if you do remember, we have taken what? This data.yaml file, which is having the file location of the images of the testing, training, and the validating. So this data.yaml has been used in the above command when we basically want to train our model. So here you can see in the data, we are having this data.yaml file. So this is actually taking all the images from the testing, all the images from the training, all the images from the validating in every epoch, and based on the labels also. So labels are basically the annotations. All right. So of every image, there is every label. So if suppose in testing there are 3,000 images, so in the labels there are 3,000 labels. So for each image, we have some each what we can say annotations, or the we can say data point, that where the image, where the fire in that image is, or we can say simply the coordinates of the fire in that image. So if we are having 3,000 images, so in the labels we are having 3,000 annotations, and in each file, in each annotation file, we are having almost different coordinates of that fire. So that is something it is basically working on. It basically works on all these different images and the labels data, and it basically retrains the model so that it is going to be having more accuracy. All right, so do try to give us more accuracy. So that is something the epoch basically do. But if you are going to increase the epoch size to 50 or 100, that is also going to increase the efficiency of your model. It can increase the accuracy of your model, but it is also having a downgrade or a disadvantage that your model might not work. All right, or your model will work, but with a very low accuracy and efficiency. So it's better to take 25 as a minimum. You can go and check with the 27, 28, 30, different scores, different accuracy scores, which we are going to get in the meantime once the model is being done. All right. So, yep. So if you do have any other questions, so do let me know. Till then, let's wait for our epochs to complete. Now every epoch is almost taking 2 minutes, right? So every epoch is almost taking 2 minutes. And by the way, tomorrow also we are going to be having webinar on the same topic, but we are going to take some different examples with more advanced approach. And if you do want to work any model, so make sure to work on that model. And if you find or face any problem, so you can ask me tomorrow as well. Okay, so if you want to try by yourself, go and try by yourself in creating a model, in going for this YOLO version it approach. All right. But yeah, if you do face or any kind of problem, you can basically ask me tomorrow. Can you let us know more about these deployment procedure of models? So as usual, Ranbir, you can actually contact the education diary, right? You can basically enroll for the program, because as usual, as I told you, that AI and machine learning is in depth. All right. So I do personally know that, yeah, you are having so many different that lectures from different sites, like you do have some Udemy and something like that. But in my entire life I never used Udemy. All right. So I do always learn from the professors, from what is actually happening in the real life. And once actually you enroll in the classes of the education diary, you will be getting to know about what actually we do in the real life, how we do, how we implement these kind of things. So that is actually you can go and try on. So once actually you are going to be having the knowledge, like the deployment procedures and the models, or what are some different models you can go and work with, so you can actually work in industry. All right, because you are going to be having an idea. Like I personally believe so. In last 2 weeks, we were having a lecture on the Amazon AWS cloud technology, but that is something not the industrial or the industry people use, right? They don't go to the Amazon AWS, they don't go and sign up, they don't actually do all those things. But that is something an introduction. So you have to do programming in order to connect with the Amazon AWS console. Then you have to upload your instance to the Amazon cloud technology. So that is something what the industry needs. All right. So if you are working in a coding in Python, C++, so it's not going to be working like that in real value, in real world. So you have to work like what basically the education diary do provides. So once actually you enrolls, you are going to be getting the industry based idea. You are going to be getting some industry based projects like capstone projects. And once you are going to be completing those projects, so you are going to be having an idea that what actually you have to do once you actually enter into the industry. All right. So any stimulator or online server is available. Tomorrow show us one or more algorithm implementation. So this is actually not an algorithm, right? So Swaran, this is actually not an algorithm which we are working on. This is pre-default YOLO, which is majorly used by the companies, right? And if we are going to implement an algorithm which is going to be in CNN, right, neural network, so that is something a different topic. We do have done this in past. You can go and check on live lectures, live webinars of the education diary in which we implemented the algorithm. We created the neural network by using CNN technology, and we basically did some detection, right? If I'm not wrong. So that is something which is already being taken up place. Okay. But tomorrow, what personally we are having a plan is to work with any other example. It's not going to be the object detection. What we are going to be working with is going to be object character recognition. So that is also something which you can go for. All right. So yeah, we are having lots and lots of things in AI and machine learning. So I think so only 5 or 6 more epochs are remain, and after that it's going to be over. All right. By the way, this last command is something really hard to execute, right? Because there are some errors which we might get. And this is fine, data.yml validations. This is actually the scores. Once our model is going to be executed, this is going to be the scores of that train box loss, training loss, precisions, metrics. So this is something a really important graph, right? And once actually you do some research, you can actually write all these different values there based on 25 epochs, 30 epochs, or 35 epochs, right? So that is really important graph to get in. By the way, if you are going to be using Windows, it might take some more time. If you're using Mac, so it's going to be easy for you. Because I do have used in Windows this form of YOLO version 8 for training the model. It took like more than usual. But if you're using Mac, so it's going to be taking some time based on the GPU of Google Cloud, but it is also going to take power from the CPU of Mac. All right. I do believe so that this webinar has been that one of the longest webinar till now. But ultimately, as usual, training the model takes a lot of time, right? So if you are in the field of AI or machine learning, that is something not in my hands as well. I do have executed in the past and I do have got the PT file in the past, but starting from the very beginner level is something which everyone can understand, that how to approach these kind of different techniques. That is actually not in my hands, so we have to wait for the model training to get over. All right. Can we reduce the number of epochs? What will be its effect? Yes, you can basically reduce the number of epochs to 10, 5, 6, doesn't matter. But 25 is something which is the minimum, we can say, suggestion by the Ultralytics, by the YOLO, or by the RoboFlow also we can say. So 25 is basically the minimum suggestion given by the Ultralytics. You can go with the 5 or 10 epochs, right? So it's not going to be reducing efficiency, but in some cases it can. So you have to restart, you have to again increase the epochs and again have to execute. So that's why if I want, I can go with the 10 epochs or 5 epochs, it will be done easily. But I do want to show you that how important it is to follow some of the rules which are given by the YOLO. All right, so you can go with 5 epochs, doesn't matter in that. So 21 epochs has been done, only 4 epochs to go. By the way, if you are willing for AWS certification, so you can actually go with this as well, right? So Amazon AWS certification. So please, if you are actually into the AI, so make sure to have this kind of certification, which is majorly being, we can say, taken up by the industry experts. So if you go into the company, if you have this certification, so they do value you. All right. So I'm just letting you, because as usual we are having 4 epochs right now. So you can also go with the CCNA certification. Now these are some of the certifications I already have. So I do have Amazon AWS, I do have CCNA certifications in the field of networking by Cisco, right? So try to have these kind of different certifications, so they are going to be increasing and adding value in your resume or CV, right? I'm not sure what is the CCNA certification fee in India. It's going to be, I'm not sure, like 25,000, 30,000. I'm not sure, but yeah, you can actually check for that as well. Apart from that, you can take for the CEH certification, which is the Certified Ethical Hacker certification. It is basically being provided by the EC Council, right? And it is also like almost $900 or $1,000 of certification, right? Now, people do say sometimes that there are no use of taking certifications if you're not having skills. That is actually true. But if you're going to be taking these certifications, they are going to be having examinations, right? And you have to pass in that examination in order to get these certifications. So overall, you have to study for these certifications. Otherwise, you will just pay money and you will not get any kind of certification. All right. So, yep. So if I increase the number of epochs, then does it mean it will increase the efficiency? Yes, it do, right? But don't increase the size of epochs too much that your model is going to be giving you errors, all right, that it may not be able to detect what you want to. So yeah, you can increase the epochs. So as I told you, you have to test different epoch sizes on that model. It can be 25, 30, 35, but don't make it like 1000 epochs or 500 epochs. It is going to be make your model corrupt, and it is not going to increase efficiency, else it is going to decrease the efficiency of your model. Okay, so almost 3 more and then we are good to go. We are having our images also upload, in which we are going to detect our model, and hopefully it should work. Now this last command should work. So let me know from which city you are, what you are doing right now. Are you doing your bachelor's, master's, and in which field you want to pursue your career? So let's wait 3 more epochs and then we are good to go. By the way, if we want, we can go with the other fire images, but once the model is actually working fine, so that's fine. Now you can take any fire image. Because it is of 3000 images, now this is basically kind of like Dia. So we can basically take this as well and we can detect the fire on this, okay? So let's have this image as well. Let's upload this image. It's in the form of WEPP. So what I can do is I can basically rename the file to only JPG. All right. Almost 3 more epochs. Now this is actually the folder which is going to be having our model, right? Runs. Now this is actually the folder which is going to be having our model best.pt. Okay, and that is something here you can see as we are using YOLO v89 or 8n.pt, so it is basically downloaded here. Okay, so you don't need to do or you don't need to work on this. What we need is best.pt, okay, which is going to be our model ultimately. Now if I go into check my storage, so you can see it is basically RAM is being taken 5 GB almost out of 12 GB, right? And if you're going to be using CPU, so it's going to be working a lot, right? It's going to be taking a lot of time. So make sure to take T4 GPU. And as usual, if I'm going to be having a less model size around 500 images or 1000 images, so the process is going to be fast for that as well. So every factor depends on your model size. So if your model size is like more than 2000 3000 images, of course the efficiency and accuracy is going to be increased for that model, but in the meantime the process is going to be taking a lot of time even after using free version of GPU. But if you do have a paid version of GPU which is like more powerful, so yeah, the time is going to be really less. So how was your journey regarding ML? So I do like machine learning, but personally if you ask me that what I do if I want to make my career in machine learning, so that is something personally no, right? Because that basically depends on interest of a person. So if you do have interest in machine learning, then go for that. If you do have interest in AI, go for that. But for me personally, I'm not in the way of doing a job in future, right? So for me in future, I want to be a professor. So that is something I'm on the way of that. So that's why the research papers are only published when you want to become a professor. All right. So if you are having a milestone of doing job, so go for that. It doesn't really matter because that, as usual, everything depends on your interest. All right. So my interest is gaining some knowledge, upgrading and updating yourself time to time, and be a professor in the field of IT. All right, because we do have, like personally I do have studied in different fields of IT, not only in AI but in data analytics, big data, Java. You basically studied in cybersecurity, information technology, blockchain industry. So as I told you that make sure to have skills in different areas, not only in one. All right, so that is something my suggestion. But yeah, I do have worked in some of the internships in companies like GMD Soft. Right now, we are working with one of a company in Korea with the name Sia Steel, right? So it basically is a steel industry or a steel manufacturing industry, and we are working with that company on developing kind of like AI model. So yeah, we are working on the companies with the projects. So all these different kind of projects helps you in getting what you actually want or helps you in becoming what actually you want in your career. All right. So if you are going to waste your time only on the college learning, so it's not going to be really working fine with you in the future. So go forward, make some projects, work with some companies, make some projects for the companies, And based on that, the companies do give you some recommendation letters, or some companies do provide you some kind of stipend. So go with that, work with the companies. That is something which is really important. So I do personally believe so that the education diary do provide some kind of internship opportunities if you want to work with. So you can work with that as well, because all these different kind of things are going to increase your knowledge. That give you some lots of contacts and approaches, some recommendations from the people. So overall, these things really helps you in the industry. Okay. So previously, before coming to Korea, I was having a plan to apply in Google. So basically, I do have applied in Google in 2022 and worked in Google for 3 months, with my, of course, the other colleagues in the Google for 3 months in Korea, in Seoul. But after that, I do personally believe so that doing job is actually not in my field. I don't want to do job. Okay. So yeah, based on your interest, everything is. So, what is a CNN? It's kind of like a neural network. So, we are having CNN, RCNN, right? RNN, sorry. We are having these NN, we are having these neural networks. So, these are form of the models, or you train the models based on these different algorithms, different neural networks. All right. So, that is something which, like, suppose I can create a CNN model for the object detection or the fire detection. I can create that. All right, but as usual, it is going to take some time. You have to program for that. You have to create a CNN algorithm, and based on that algorithm, it is going to create a model for you which can detect fire. But why to take such long process? Because CNN is slower and having less accuracy than your YOLO. All right, so if you're going to compare CNN or any kind of neural network with a YOLO, so it is having low accuracy and low speed. So if you want to get more speed or more efficiency, more precision scores, go with the YOLO. All right. So our last epoch is almost going to be done. Finally, I think so. This webinar is going to be almost 2 hours of webinar. But it was really important and essential for you guys to understand that how actually the thing works, right? How we can actually train the model, and how can we actually use the model. All right. So let's go and let's see if our last command executes properly, because that is the ultimate test. By the way, it is going to give us some information that where the best.pt file has been saved. So as I told you that in runs and in detect, we are having two folders with the name train and train2, but I don't know in which folder this model is going to be get saved. So ultimately it's going to be telling us that this is your best.pt and this is the folder. So make sure to take your best.pt from that folder only, right? So yeah, you may have to make some changes, configurations, file locations in the commands of the YOLO. Okay, so 76%. So human brain, no. Actually, the CNN works on the neural networks which do tries to mimic the human brain network signals. So, but it is not working like a human brain, right? So that is something not the case. So almost the epochs are done, and so let's see, everything is done. Now it's going to tell us that where our best.pt file is. All right. So here you can see that the things are saved in runs detect train2 waits dot forward slash best.pt, right? So it is basically telling us that it is in train2 folder. All right. Now it is going to take and give us some scores of every MMAPs and so much things. And the results are saved in runs detect train2. All right, so the command is run. Let's refresh this. And it is telling us that results are saved in detect train2. So the results are F1 score. Now here is the F1 score. Double click on this, and here you can see that this is going to be the F1 score, right? The confidence level is between of 0.5 almost. So that's totally fine, right? So F1 score is this. You can go with the PR curve. You can go with the R curve. So if I click on R curve, so this is going to be the recall confidence curve. So it's fine, right? So it's almost giving us the 1 score. So that's really great. Now let's execute the last command. let's go in the weights because our file base.pt is in the weight. So we can basically copy the path from here. We can delete this. We can paste this here. And our source image is going to be this one, or let's take any image. So that's totally up to you. I can take this image, copy path, and are going to be source here, right? So if I run this, it should work. All right, so the results are saved in runs detect predict. So if I refresh, so runs detect and predict. So here is our file. So if I double click on this, so here you can see that this is the fire. Now this is actually working, right? So it basically tells us that yes, this is actually the fire in our image. All right, I can change the image. I can delete this, right, which is the predictive value, predictive image. I can take any other image if I want. Let's take this one, copy path. Let's change this source to here. Now let's run this and let's see, it's going to give us again. So predict 2, now the file is being saved in predict 2. So let's refresh, predict 2 is here. Let's double click on this JPEG and here we are, right? Now the important thing you can see in this image is that yes, this is the fire, but this is the reflection of fire in the water. All right, so that is something which is depends on the epoch sizes, the more and more images file. But yeah, you do have the example that how the things are working. Now this is the reflection of fire, but it's still working. All right, so let's close and let's try to work with the diya. I think so that was the file which I do have taken night light. This is the one, copy path, and let's change the source. Let's run and it will be giving the predict 3. All right, so yeah, it basically gives us the file in predict 3. Let's refresh and here we are having predict 3. Let's double click on the image. So here you can see it's not working, right? So here you can see that the fire is unable to detect because for the model, this is not fire. This is just kind of like a normal fire. All right, but if I do take any other image which is having fire inside this, so suppose if I take this image and if I save this, let's rename the file to test. Let's upload this test. All right, so here we are. Let's copy path, close this. Now if I change the source, predict 4. So let's refresh. We are having predict 4. Let's check this file. And here also you can see that for the model, this is not a fire, right? So you can see that in some of the images that the model can recognize the fire, but in some models, it is unable to recognize. As usual, I told you the more epoch sizes, so you have to work with different epoch sizes and of course the model itself. If you're having more images of more and more different kind of fires, so it will be recognizing that. But if it's not having this, so suppose in predict 2, we were having our image, which basically it recognized, right? So you have to make your epoch sizes different and based on that only it will be working. All right, so I do think so that all the images has been tested and out of 4, 3 images worked, but one image which we downloaded, which is actually 5 out of 5, 3 images has worked, 2 are not. All right, so that is something the overall view of the webinar today. And if you do have any other questions, so do let me know, right? You can send an email to the education diary, or if you do want to enroll for this AI program, so you can contact the education diary by the email, or you can actually WhatsApp them or call them. And this was it for today's webinar. We are going to meet tomorrow on the same topic with a different examples and more advanced approach. Till then, take care everyone and bye.